In the early 1970s, the Anglo-Australian Observatory, or the AAO, has been keeping a sharp eye on the southern skies. Along the way, it has built up a reputation as one of the world's best astronomy institutes, despite only having two telescopes, both over 20 years old. The AAO owes its success to skilled engineers who are always developing new technologies to get the most out of their telescopes. Until recently, most of the world's major observatories were located in the northern hemisphere, which meant that half of the celestial globe was relatively unexplored. To address this imbalance, the governments of Australia and the United Kingdom made a pact in 1970 to establish a major observatory in Australia. But the new observatory offered the chance to examine many of the nebulae, galaxies, and stars that cannot be easily visible from the northern hemisphere. The location chosen for this new Anglo-Australian Observatory, the AAO, was Siding Spring Mountain in the state of New Wales, Australia. The site of this obvious choice being within 2 hours of flight of Sydney, while still retaining very dark skies. Australia lacks the high mountain ranges that elsewhere provide ideal conditions for observations. But the 3,700 feet, nights in Siding Springs are a clear 65% of the time. Today, the AAO operates two major telescopes at Siding Spring, the Anglo-Australian Telescope, the AAT, and the United Kingdom Schmidt Telescope, the UKST. The first to be established was the UKST in 1973. Its 1.2 meter telescope has a wide-angle field of view and is specifically designed to photograph the night sky. Together with another Schmidt telescope in Chile, it has been used to compile the Southern Sky Survey. This forms a photomosaic of the southern sky from -17 degrees to the South Pole. The UKST has also carried out its own near-infrared survey of our own galaxy, the Milky Way. The second telescope operated by the AAO is the 4-meter Anglo-Australian Telescope. This was established at Siding Spring in 1974 and has remained at the forefront of astronomy ever since. The basic telescope has not changed, but the instruments that are used within it are constantly upgraded and new ones are developed. The AAO's engineers specialize in instruments that collect infrared light. When these are filtered to the AAT, the telescope can be used to examine objects that are too cool to emit visible light. The most recent such device, called IRIS, the Infrared Imaging Spectrometer, was used to observe the impact of comet Shoemaker-Levy 9 on planet Jupiter in 1994. The most frequently used of the AAT's add-on instruments are spectrographs, which split the light from celestial objects into their constituent colors. Analysis by astronomers of the resulting individual color spectrums reveal properties of the object, such as composition and temperature, that ordinary images cannot show. Foremost among the equipment developed for the AAT is the so-called 2-degree field facility, the 2d F, which harnesses pioneering research work carried out by the AAO engineers into the use of optical fibers for astronomical observation. The 2DF contains flexible optical fibers that can collect the light from different objects within a 2-degree area of the sky, about 4 full moon diameters. That's a lot. This increases the AAT's field of sight by the factor of 4 and allows AAO astronomers to see over 400 deep sky objects in a single frame, a previously unheard rate. The telescope of AAO may be old, but the technology of the instruments that go with them are state-of-the-art. Together, they ensure that the eyes of the southern sky stay sharp. Remember to like, share, and subscribe to my channel, and if you enjoyed it, then again, like, share, subscribe, whatever. But if you did, do so, and have a good one.